This is Kosmographia, the Randall Carlson podcast.
Sorry. Oh, yeah.
Right there.
Okay, so the grazing event is all the stuff from the tail. Is that what you're saying there, or do you think that the nucleus also comes through the?
Well, because what's happening, is anytime a comet comes near, like a source, a strong gravity field, it's going to begin to disintegrate.
Yeah.
And that's what we're looking at here. We're looking at a series of disintegrations, perhaps spread over thousands of years. But at one point within that cycle of this comet disintegrating, Earth had a very close encounter. And I would suggest that the closest encounter would be the Younger Dryas Boundary. But that was probably not the only encounter, because if you've got this very large comet, which might be 60 to 100 miles, diameter nucleus regularly circling between Jupiter and the sun, there could be multiple episodes where Earth is encountering the debris of this disintegrating nucleus. But so that's what I was trying to show here, that basically this was a grazing. And see, actually, if you look at this diagram, you see this blue tail. This is the gaseous tail of the comet. This is actually the trail.
Those are the, okay.
That's thousands of smaller. See, the idea here is that this comet nucleus might be 50 to 100 miles in diameter. This stuff's falling off of it. There could be actually literally millions of pieces falling off. Yeah. The smallest of which are going to be in the range, of Chelyabinsk or Tunguska. So this does is create the opportunity for multiple impacts over, like Klube and Napier and others have been saying for years. There's evidence that there are bombardment epochs. Yeah. And this would be associated with the destruction and disintegration of large comets, which they speculate, I think, would enter the inner solar system approximately once every 100,000 years or so, or maybe even more often. I haven't seen their latest dating for that, the latest tempo, but often enough that it could have major consequences for terrestrial life.
The other interesting thing about a grazing object like that is that it stays in the atmosphere a lot longer than, a much more vertical impact. Those can be in the atmosphere like a couple of seconds, but this thing can be burning through the atmosphere, exploding, dropping things, and putting heat out for a long time before it goes back out into space.
Yes. Yeah. Yes.
The other thing I was thinking too is that if it grazed the planet, that would obviously, that's a really close approach. So it would have changed its orbit probably enough to where whatever it was before that was regular enough, it moves it out of that regular orbit, and who knows, it could have hit Jupiter, it could have
been swallowed up by
the sun or right. And so what happened after maybe 1,000 years later or whatever is that we're running into bits and pieces of the tail.
Yeah.
Mm-hmm. And their point is that there could still be enormous amounts of this debris
right
still circulating out there. And interestingly, as we get better and better capable of taking a census of what we share nearer space with, it certainly does seem like it's a lot more densely populated than anyone was imagining a few decades ago.
Right.
So then, same team, Proceedings of the National Academy of Sciences, in 2009 published a report entitled Shock Synthesized Hexagonal Diamonds in Younger Dryas Boundary Sediments. Here, we present evidence for shock synthesized hexagonal nanodiamonds, or Lon's Delight, in YDB sediments in North America. The diamonds occur in a discrete layer that is contemporary with and similar to the organic-rich sedimentary layers described by Vance Haynes across North America. The best known geological exposure of this dark sedimentary unit is 1.35 kilometers from the modern coastline on the west side of the canyon. And here they're referring to a canyon that is, as I recall, was on the Santa Rosa Islands, one of the main islands of the Santa Rosa, where a 44 centimeter thick, now that's pretty thick, organic rich dark blue-gray silty mud black layer rests directly on a gravel deposit, right? Now, the rest of the overlying sequence consists of alluvial sands and gravels. Alluvial, what does that mean? What does the term alluvial mean?
Isn't that a
Water?
river?
Water, flowing water, yeah. Accelerator mass spectrometry, or AMS, carbon-14 dates from upper and lower parts of the sequence are statistically similar, suggesting rapid accumulation of fluvial deposits shortly after 12.9 Ka. Now, think back to what we were talking about, rising of the water table, right? Here we have evidence of rapid accumulation of fluvial deposits right after. So what it appears is if there was major climatic episodes that included, if it's alluvial deposit, that means flowing water. If you've got flowing water, you've got to ask, where's the source of the flowing water? And when you start looking at all the possibilities, the one that stands forth most prominently would be rainfall.
Torrential rains. Yeah.
Torrential rains, yes, exactly. They go on to say that these shock synthesized diamonds are also associated with proxies, indicating major biomass burning, such as charcoal, carbon spherules, and soot. This biomass burning at the Younger Dryas onset is regional in extent and coeval with broader continent-wide biomass burning. Biomass burning also coincides with abrupt sediment mass wasting and ecological disruption, and the last known occurrence of pygmy mammoths on the Channel Islands, correlating with broader animal extinctions throughout North America. And I will pull up a Google Maps here so that people can see where the Channel Islands here are that we are talking about.
All right, we see it.
West Coast, Los Angeles. We'll go right down here and let's see. Here we go. In fact, here's the Channel Islands, which during this episode, these weren't separate islands. They were one single landmass. But Santa Rosa Island is where this canyon is that they were making these investigations. Santa Rosa Island. So, yeah, so they were actually occupied by mammoths, but these mammoths were smaller because apparently their territorial range was smaller, so they adapted by becoming smaller. But the extinction of these pygmy mammoths on this island, like as they said, coincided with the much more broad-scale, continental-wide mass extinction of the megafauna that occurred. So that's the islands that it's talking about here.
The proboscideans.
Proboscideans, yes. Like you've heard the term proboscis, which means
Schnoz.
nose, schnoz. Yeah. They go on to say that the presence of shock synthesized hexagonal and other nanometer-sized diamonds in Younger Dryas Boundary sediments in association with soot and other wildfire indicators is consistent with a cosmic impact event at 12.9 Ka. And the hypothesis that the Earth crossed paths with a swarm of comets or carbonaceous chondrites producing air shocks and or surface impacts that contributed to abrupt ecosystem disruption and megafaunal extinctions in North America.
Man.
Yeah.
So that's still what year is that now?
That was 2009.
Still 2009. Okay.
Yeah. Right. So,
Presentation at the meeting.
Yeah.
Okay. Yeah.
so then independent, let's see. So here we have another independent team led by T.W. Stafford. Oh, actually, no, but that's the leader of the team. But yeah, they brought in Kennett and West and Wolbach. But this is a testing the Younger Dryas impact evidence at Hall's Cave, Texas. This was the American Geophysical Union fall meeting 2009. You know where that is? Hall's Cave, Texas?
No, I don't.
Near you guys?
Sounds somewhat familiar. No.
Don't recognize it.
Yeah.
Hall's Cave. While we're going on here, Kyle
Check it out.
might bring that up and see exactly. It's in Kerrville County,
Oh my God.
southwest of Austin.
Kerr County. K-E-R.
Kerrville County.
Kerrville County.
That's like we work in Kerrville.
Yeah.
Hall's Cave, Kerr County, Texas.
Holy crap.
Hall's Cave. Yeah, there we go.
All right.
So we're bringing it home, guys.
Backyard.
Bring it on home. Backyard, yeah. So Hall's Cave in Kerrville County, Texas, provides a unique opportunity for testing the presence of here's a word everybody needs to learn and get down, chronostratigraphic datum.
Right.
A chronostratigraphic datum.
Is the black mat there?
Excellent.
Because
Well, we'll see here. This is in a cave. Let's see what they say. So this is a unique opportunity for testing the presence of a chronostratigraphic datum, in parentheses, the YDB layer, containing rare and exotic proxies, including nanodiamonds, aciniform soot, which is a type of soot that's characteristic of intense wildfires, okay, and magnetic spherules, the origins of which remain controversial, but possibly derived from a cosmic impact 12,900 calendar years before present. It's a karst collapse cave in Cretaceous limestone on the Edwards Plateau.
Yep.
Karst is when you have limestone, it's erodible by water, particularly if the water is somewhat acidic with a low pH. And this is why you find so many caves in limestone bedrock country.
Yeah. They call them
it's-
karst windows.
Call them what?
Karst windows are the openings to the surface.
Yes, karst windows are the openings. Exactly, right. So this is talking about it's a karst collapse cave in Cretaceous limestone on the Edwards Plateau. It contains 3.7 meters of stratified clays, grading into clay silts and recording continuous deposition from 16,000 radiocarbon years ago to the present. The cave's small catchment area and mode of deposition were constant, and the stratigraphy is well dated on 162 accelerator mass spectroscopy carbon-14 dates from individual vertebrate fossils, snails, charcoal, and sediment chemical fractions. The cave sequence contains an abundant small animal vertebrate fossil record, exhibiting biostratigraphic changes, and the timing of the late Pleistocene megafaunal extinction there is consistent with that elsewhere in North America. And at 151 centimeters below the datum is an extremely sharp, smooth contact separating the lower layer clays from an overlying dark reddish-brown clay layer that dates to 13,000 Cal BP, calendar years before present, at or close to the age of the Younger Dryas Boundary datum elsewhere. This appears to be the most distinctive lithologic change in the deglacial sequence. And then he says that there's a local extinction of 4 species of bats, prairie dogs, and perhaps other burrowing mammals, and the uppermost occurrence of 6 late Pleistocene megafaunal taxa, or in this case species, do not extend younger than 12.9. So right there, even these small animals are dying off. So he goes on to say, we collected and analyzed sediments at high resolution above and below the distinct lithologic contact at 151 centimeters. The red clays, which are only 2 centimeters thick, and immediately preceding the lithologic contact do contain an abundance of nanodiamonds, aciniform soot, magnetic spherules, carbon spherules, all of which we interpret as evidence for a unique chronostratigraphic marker in the Western Hemisphere. Because the age of this horizon is approximately 13,000 years, we interpret the age of the event as the beginning of the Younger Dryas cooling. So there we have now evidence from a cave in Texas. And as we go, we're going to find out that, there's...
I really want to give you a high five right now.
Yeah. We're going to go to that
I'm
cave.
really excited about this cave. We're going to go check it out.
Yeah.
Oh, really? Good. All right. That's...
Flip back to that. We were looking at this. Yeah. 48 species, 62, the remains of 62 species of mammals and at least 48 species of non-mammals. Wow. That
Been found in the cave?
Yes. Yep.
And it's in your county?
It's next door to us. Yeah. The next county over. The place we work like every day in Kerr County. Yeah. Wow.
Wow.
I feel dumb.
And so you guys didn't even know this, did you?
No.
That's
yeah,
awesome.
I hadn't had a chance to look it up before, but I saw that and I thought before our podcast this evening that I wonder if those guys know about that cave, or I wonder if it's near them.
Surely they've been there.
So let me get this straight. The deposition is inside the cave.
Yeah.
Yes.
So the cave itself is
It collapsed.
like the opening is older
Mm-hmm.
at least than the Younger Dryas boundary. So that
I would think it would have to be.
right, because it had to come into the cave and then it was preserved. It didn't get eroded away.
Exactly.
In this cave. I've been wondering why, we don't have any. Where are the layers? There's mammoths here. We don't see the black mat anywhere around here, but I was assuming must have been eroded away since then.
Yeah.
Well,
But-
in some places it would have been.
Yeah. Fascinating. So thank you
Mhm.
very much for revealing
and
that fact.
Yeah, I think they were saying it collapsed, so that gives it the sediment. The bottoms of the sediment start 16,000 years ago. So
Right.
the cave,
Yeah.
there was no karst window,
Right.
and then 16,000 years ago there was a collapse that allowed sediment to start coming in, and it made this perfect record all the way.
Yes.
We're going.
Yes.
And so for now 13,000 years it's been waiting until you guys got there.
Right. Now here we are.
I'm in love with you, cave.
Yeah, so you guys just go in there with your shovels and start digging.
Right.
Got to find the stratigraphic context.
I think you would
It's
be
there.
We would
Yeah.
in chains. Yeah.
Let's move on to 2010.
So,
And there's more.
Oh, there's more.
Yeah, and we've just passed the hour mark, so
Okay, so we'll go a little bit longer. So I will do a screen share here, and we will look at a graph. This was published in 2010. This was from a paper published in Geology in 2010. What Caused the Younger Dryas Cold Event by Anders E. Carlson. And basically what this graph is showing, this is from a core sample taken from the Greenland ice sheet. And up here at the top, this graph shows nitrate concentrations, and the one B over here shows ammonium concentrations, and the gray bar defines the Younger Dryas. And so what you see here, notice this, the nitrates and the ammonium spike. Now, both of those are proxies for intense wildfires, forest fires on a grand scale. And then the oxygen isotope scale is what this you see on the bottom here. And so you'll see that the temperature here drops. See, this is the Younger Dryas beginning, this drop. We've looked at this graph before, right? Here's the drop down and then the climbing up out of the ice age, right? This is the Younger Dryas, but this gray bar represents the peak of the Younger Dryas. And so what you see here is you see this massive spike of nitrates that is associated with the Younger Dryas. You also see a very large increase in ammonium. In fact, there's a spike that comes up here that's really tall. So these are proxies for wildfires. So what this is showing is that we not only had the onset of wildfires at the beginning of the Younger Dryas, but we had a succession of wildfires, which would actually make sense because in the aftermath of the Younger Dryas event, we're probably looking at initially a minimum of somewhere around 10 to 15% of the global biomass consumed in wildfires. But in the aftermath, as a consequence of the cold that came back during the Younger Dryas boundary, you would have a massive die-off of vegetation. And so now what this does is create a huge fuel load for subsequent forest fires to continue throughout the Younger Dryas because of all the basically the dead fuel, the dead forests that are found all over the place.
And then you have more lightning because of the storms that are happening and stuff. So you end up with fires.
Yeah. This is an interesting graph. I won't spend quite as much time on this because this is actually a sea level graph. And what you see here is we'll get into talking about this too, but notice there are 4 events here, almost periodic. You'll notice we go, the age bottom here, we go back. This one would be what, 310, 20, 30. So about between 330 and 340,000 years ago. Then you come here and just about 240 to 250, you've got another one. Then at about 130 to 140, you have another one. And then this is the one associated with the Younger Dryas. And so it seems like we've got almost a rhythm of these kinds of events. Although, to my knowledge, studies have not been conducted to really look for impact proxies at these other events. It's probably worth doing. Of course, the problem is that, you know, each time you have a catastrophe like this, it tends to obscure, erase, or eliminate a lot of the evidence that would have existed for an earlier catastrophe. See? So that's one of the problems there. So
yeah, that makes sense. I mean, the most recent catastrophe is going to be the one that's easiest to see.
Which is going to be the easiest to see, yeah.
But it is strange that the scientific community has accepted the proxies for the older ones.
The KT, yeah.
And yet, when we find so many of those same proxies, they're like, yeah, but you didn't find all of them.
Or, you don't have the crater yet.
Uh-huh.
I mean, proxy they want.
Back to this study by Kennett and them, what they did was they took 27 sedimentary samples from Arlington Canyon, which is on the north side of Santa Rosa Island that we just looked at, okay? So at 12,900 years ago, because of lowered sea level, this island was joined into one landmass along with the San Miguel and the Santa Cruz Islands, okay? So what the Kennett team found in an exposure of the west wall of the canyon was 2 layers of dark, silty, muddy deposit at a depth of between 4 and 5 meters, or between about 13 and 16 feet below the surface. In these 2 layers, they discovered what they reported to be shocked nanodiamonds, and in this case, the special form of nanodiamonds called lonsdaleite, along with carbon spherules and lots of charcoal. So in their 2009 report, they state, here we present evidence for shock synthesized hexagonal nanodiamonds, which I already read to you. So we pointed out that the gravel deposits are typically evidence of vigorous fluvial currents, as would be associated with a flood. So separating the 2 dark layers, there's another layer of quartz gravels about 2 feet thick. Over the uppermost dark layer, it's about 2.5 feet of very coarse gravel to rounded cobble-sized rock. Again, evidence of a significant flood passing through the canyon. Immediately after deposition of the second layer of dark mud. Overlying the cobble gravel deposit is a layer of coarse sand about 1.5 feet thick, and dating of all of these layers puts them right at 12,900 years before present. So they say, yeah, the rest of the overlying sequence consists of alluvial sands and gravels. AMS carbon-14 dates suggest rapid accumulation of fluvial deposits shortly after the 12.9 thousand years ago. So in other words, the deposition of the nanodiamond layer was immediately followed by floods. So then, let's see what go on here.
It's hard to imagine that not resulting in it just being mixed up everywhere.
Yeah.
The black mat layer, you know.
Right. Well, here it's much thicker. You don't find that discrete.
Yeah.
It's distributed through this much thicker clay layer. And then it was on Santa Rosa Island where they discovered a pygmy mammoth skeleton. And this was published in 1998 in the Contributions to the Geology of the Northern Channel Islands. This was by Larry Agenbrod, who was the head paleontologist at the Hot Springs Mammoth site in South Dakota, which Brad and I visited along with Graham Hancock back when we did our tour together. We went to the Hot Springs Mammoth site. He says, so Agenbrod said that the 1994 discovery and excavation on Santa Rosa Island of the most complete pygmy mammoth skeleton yet recovered prompted additional research of the California Channel Islands. An intensive pedestrian survey of mammoth localities tied to GPS coordinates was initiated for the first time in the history of the island mammoth research and has resulted in the discovery and documentation of more than 100 new mammoth localities. So from that, it would seem that mammoths were quite prolific on the Santa Rosa Island, which again, it was what is now 4 separate islands, was one much bigger island. So then they did a study on the femur, dated it by AMS, accelerator mass spectrometry, and it dated at 12,849 years. And then there was a female remains found, and this was published in, let's see, this was I was not able to track down the original paper published on this, but I did find a account of it in the Los Angeles Times that was dated April 11th of 1987. And so they found the remains of a female buried in Arlington Canyon on Santa Rosa Island. So quoting from the Los Angeles Times, dated April 11th, in a discovery that sheds new light on the human conquest of the New World, a team of scientists says that the bones from an ancient woman who lived on the Channel Islands off Ventura County could be the oldest human remains ever found in North America. The extraordinary discovery provides important clues to a critical yet mysterious period in human history, the end of the last major ice age, when nomadic people began populating the Americas, but left little evidence about who they were or where they came from. I'll pause there for a second because this brings us back to one of the overriding questions when we begin to look at this, is that when we talk about the Clovis, which we will continue to be talking about and looking at the evidence for this culture called the Clovis that left the figments of their culture all over the continent, right? But unlike the megafauna, we don't find where are the remains of the Clovis people.
Where are the bones? Right.
Where are the bones? Yes. It's almost as if you have this evidence of the quarries, of the campsites, the tool making sites, the mounds of debitage left over, all over 50 sites at least in unglaciated North America. But where are the bones?
Right. Anzac 1.
It's almost,
I don't know
yeah.
about
Yeah, that's the only
I'm-
one.
I'm-
Yeah, we don't know.
I
Yeah.
got a whole conspiracy about this, conspiracy theory about this, but I don't
Well,
want to
we'll look at that, and if I think that it's plausible enough, we can talk about it.
All right.
I don't know.
Okay, so bottom line is she may be the earliest inhabitant of North America we have discovered, said John R. Johnson, curator of anthropology at the Santa Barbara Museum of Natural History. It is a find of national significance.
How old were they thinking she was? Sorry.
The article goes on to describe the more precise dating performed on samples taken from the bones.
Okay.
The tests were performed by Stafford Research Laboratories in Boulder, Colorado, one of the nation's preeminent carbon dating labs. The results shown that the bones are right at 13,000 years old, or 1,400 years older than previously thought. Now, given a margin of error of a century or two on either side, that puts the date of these bones right there, almost at the Younger Dryas Boundary.
Now, does it describe the, like, are they articulated? Are they disarticulated? Are they fragments? I can't.
I think they're disarticulated. Yeah, I don't think it's not a fully intact skeleton. I don't think.
Not a burial, probably.
So it's maybe just fragments of bones. Then.
Yeah. Yeah.
Well, it goes, yeah. So that would make the so-called Arlington Springs woman slightly older than the oldest known human skeletons in North America, which came from Montana, Idaho, and Texas, scientists say. So here we have what appears to be a deposit of flood sediments dating right to the onset of the Younger Dryas. And the question I would ask is, was she a victim of the catastrophe?
Right.
And then I ask this question, were there others who might have perished at the same time? And while we have no specimens of other humans from this place and time, we do have remains of now extinct mammals. So then that gets into what I was just talking about with the pygmy mammoths that seem to be dating from the Younger Dryas Boundary. So yeah. So then the Kennett team looks at and finds that there were shock synthesized diamonds, also associated with proxies, indicating major biomass burning.
She's called the Arlington Springs woman.
Yes.
Okay.
Yes.
Marking it down.
It's fascinating stuff.
Yeah.
What a mystery.
Yeah. Where they
Yeah.
at?
You've got it solved, though, right?
You're gonna do is
Who,
the-
me?
gonna
I'm getting pretty close.
The end.
I should have it solved within a few minutes after concluding our podcast tonight.
Yeah.
Yeah.
Tune in next week, folks.
So then I think we should also look at some of the skeptics and critics, because while all this is published, you've got this other group over here that's claiming it's all BS, basically.
Yeah.
Yeah. So I think maybe that's what we'll save for our next episode,
Okay.
because it'd be worth spending half an hour on looking at the arguments. In fact, we'll start with a paper by Mark Boslow, published in 2012, called Arguments and Evidence Against a Younger Dryas Impact Event.
Okay.
I think that would be worth doing.
I agree.
Mm-hmm.
All right.
Because the critics do make some valid points. I don't ultimately agree with their conclusions, but they do make some valid points. And of course, this is how science works, is because you propose a preposterous theory and it needs to get challenged. And the Kennett West Firestone team and the Comet research team have been very diligent about responding to their critics. And I think it would be very worthwhile to look at some of the back and forth that has taken place, because this is obviously a very controversial idea that has ramifications for our modern world, because basically it brings cosmic catastrophe and puts it right on our doorstep. And it has implications, particularly in the context of being now partaking of the sixth great mass extinction in Earth history, which is being claimed by a lot of people. There's a group, you probably heard of them, the Extinction Rebellion.
Yes.
That is claiming that we are now perpetrating an extinction episode that would be far worse than the Younger Dryas Boundary, because it's equivalent to the Great Five in Earth history, including the Permian Triassic, when 95% of all marine species disappeared, including the KT boundary, right? And we will devote at least a couple of episodes to looking at the Great Five, because I think it's very important to have a better understanding of when we're being told that we are now perpetrating something on a scale equivalent to those. Let's look at what those were so we can understand whether that's believable or not.
Yeah.
Are we now, contributing to a mass extinction that could be equivalent, say, to the KT boundary? And my initial thought is, given that there was evidence for, worldwide firestorms at the KT boundary, that there was evidence of a massive influx of particulate matter into the atmosphere that would have caused a cosmic winter to descend over the Earth. When there was gigantic volcanic eruptions spewing trillions of tons of sulfate aerosols into the atmosphere, literally producing acid rain with a pH of 1.
Oh.
We could go on. I mean, we could go on here, but it's definitely worthwhile looking at the evidence for those Great Five in much greater detail, because then we'll be in a position to evaluate claims that what's going on right now is equivalent to that.
Great. I'm down.
Yeah.
I'm down, man. Yeah. So we talked about some of the early research from 2007 now up to 2009, and where independent teams are actually just looking for the first time for these things, because they're, these kinds of impact proxies like nanodiamonds and microspherules and magnetic grains are not going to show up to the naked eye.
Right.
You've got to go hunting for them, and you've got to use very rigorous protocols to find them, isolate and find. And we will look at why some of the skeptic teams were unable to replicate the work of the Comet research team, which I think it's important to look at, because what we're seeing here is kind of almost the embodiment of how the scientific process works. It's a great example of it. Although, when we look at some of the, I would say, the attacks by the skeptics, there seems to be an attitude there.
That's sort of part of the scientific method. I mean,
Yeah.
you look at the history of science, it's been
Yeah.
doing science and also being really mad at other people also doing science.
Yeah.
Pretty snarky, like full snark.
Yeah.
Full on snark. Yeah. So, let's see.
I'm also fascinated by the concept that over many parts of the globe, there's a layer that's not that far down underneath the ground that's full of diamond dust. Like, can we sort this stuff out? Like, what would a handful of sorted, nanodiamond dust look like?
Right.
Fairy dust, man. Come on.
Well, yeah, it wouldn't look like anything, I don't think.
If you just had it, like a pile of it in your hands, like a ton of nanodiamonds, enough to make a pile of dust.
Yeah, it'd be really fine stuff.
Right. It'd be very fine and sparkly. It would be awesome.
It would probably be sparkly. Yes, it would probably be
Nano.
sparkly. Yeah. Nano, exactly. Right. Nano.
You
You
guys,
mix it up and make a shake.
Mm-hmm. So I think that's probably a good terminating point for now. Of course, we'll pick this up next
Heavy
week.
duty. Yeah. Good stuff, though. Yeah.
Yeah, what I'd like to imagine that we're going to do here is, over these episodes here, we will provide a source of information and insight into this Younger Dryas boundary that's sort of unique, because I so that between what we're doing and what Cosmic Tusk is doing, if people really want to immerse themselves in it and try to really learn about it, we will provide the resources to do that.
Right.
Yeah, excellent. More.
Yeah.
More. Yeah.
That's right. So once again, the cosmictusk.com has many resources on this and an excellent bibliography of papers and other relevant materials, including the critical ones.
Yeah.
Yeah. Easily labeled, color coded. So you can see here's the.
That's what Cosmic Tusk has done. His.
That's right.
Yeah. And I have pretty much, I probably have every one that they have, except maybe I'm missing a few of the ones that came out in the last year or two. But I also have some, because they basically started with the Firestone paper.
Yes.
I've got a lot of earlier stuff, which is when you go through and start reading it, you understand that it was already vectoring towards that conclusion.
Yes.
You see. Here's a title of a couple of the critical articles. Here's one: The Younger Dryas Impact Hypothesis, a Requiem.
God.
Like, nah, we're just going to put this thing to rest.
Yeah.
Then here's the title of another one: The Younger Dryas Impact Hypothesis, a Cosmic Catastrophe. Another one is Impacts, Mega Tsunami, and Other Extraordinary Claims. The idea, extraordinary being, well, it's so extraordinary, it's outside the bounds of what we consider acceptable science.
Yeah.
You read these titles here and you can almost hear the snorts of derision.
Snorts.
I was going to say.
Yeah, you can almost hear them.
Comes.
Mm-hmm.
Brad's got it, getting it down.
Well, again, I keep thinking of Monopoly Guy.
Right, exactly.
Of course.
Ace Ventura too.
Brad, if we put some glasses on you in that mustache like he had.
Monocle. He needs a monocle.
Monocle, yeah, the monocle.
Yeah.
Yeah.
I'll give it a shot.
All right.
So much for Monopoly Guy.
Yeah.
Fantastic, Randall. Thank you.
Excellent. Yeah. So everybody can get a hold of us, Kosmographia018.2 Go to the website, Kosmographia.com. You can find the link to the Patreon site there, and we are getting a donate button there, a one-time donate button there as well. That actually should be there by the time people see this and hear it.
Yeah, and thanks again to all the Patreon supporters. You don't know what this means to us. This is very, very much appreciated.
Yes.
And again, I said this before, and we're agreeing as we're getting this underway and find ourselves with a little more time available, we're going to have do some things.
Yes.
To reward all of those who've been faithful subscribers and Patreon supporters.
Right. And we are already, the resources that have been coming in from all of the donations is helping us already to step up certain things. We are getting ready to invest in, upgrading certain things to help the quality of the podcast. So thank you guys so much for that, because that's really helping us out. What else? What am I missing? Patreon.com/Randall Carlson. So thank you guys so much. I think that's it. Yep.
Thank you.
Let's run it. Good.
All right. Good night, gentlemen.
Good night, everyone.
Good night, as always.
See you next week.
This is Kosmographia, the Randall Carlson podcast.